I'm Daniel Levine, and this is the Bio Report. Current treatment of acute myeloid leukemia generally consists of chemotherapy followed by a hematopoietic stem cell transplant to eliminate any remaining cancer cells from the bone marrow. Even though outcomes remain poor, with around 40% of transplanted patients experiencing relapse and patients who do relapse having 2-year survival rates of less than 20%, the approach has changed little in 40 years. One reason is that newly transplanted patients are unable to receive targeted cancer therapies, since those therapies would be toxic to the fragile transplanted stem cells. Vor Bio's solution is to edit the stem cells prior to transplanting them so they lack the receptors targeted therapies attack. We spoke to Robert Eng, President and CEO of Vor Bio, about the company's platform technology, how it works, and why this has the potential to change outcomes for patients with AML and other hematologic malignancies. Robert, thanks for joining us.
Oh, thank you for having me, Danny. It's a privilege.
We're going to talk about acute myeloid leukemia, Vor Bio, and its innovative approach to address a long-standing problem with the way the condition's treated. For listeners not familiar with AML, perhaps we can start there. What is AML?
Sure. AML is a cancer of the blood system. In fact, it is a cancer that's very common. It's actually the most common acute cancer in adults. And it affects something called the myeloid compartment, where blood cells that arrives from the bone marrow become cancerous. And in some ways, it takes over the bone marrow, squeezes out healthy cells, such that patients end up getting all kinds of problems with anemias, clotting issues, and eventually, it's almost inevitably fatal. And so it's a cancer which, unfortunately, it hasn't had much innovation outside of something that really remarkable happened about 50 years ago. Someone actually invented a process called a stem cell transplant, where you could provide cells from a healthy donor into a patient, essentially replacing the damaged marrow and cancerous marrow in a patient. And that's amazing to think that cells can actually potentially live forever from a healthy donor into a patient. Outside of that, though, there really hasn't been any really remarkable innovations treating acute myeloid leukemia in our space today.
How does AML manifest itself and progress?
So AML, it has a variety of different types of presentations. It can happen even in early ages, even in kids, although most commonly happens in adults and becomes more common as you get older. Sometimes it just manifests by people just feeling tired. Some people might experience unusual bruising. Some might be much more prone to infections. And so it can have very non-specific presentations, but can certainly cause really rapid deterioration of health and, of course, ultimately mortality.
What treatment options exist? Is it just the stem cell transplantation? Are there other therapies that patients can use?
Yeah, so the mainstay of therapy actually to begin with, even before the transplantation, is chemotherapy. Chemotherapy is a bit of a dirty word, but actually in acute myeloid leukemia is actually pretty successful. There's a standard regimen called 7 and 3, which is all dictated by the number of days you receive it. But this 7 and 3 chemotherapy is actually effective in around 70 to 80% of patients to get them into a status which is called pathologic remission. Pathologic remission means that you can no longer see these cancer cells in the bloodstream. And that's really what is required in order to be eligible for transplant. So the mainstays of therapy really are, for those who can tolerate it, receiving chemotherapy, and then going on to a stem cell transplant.
And what's the prognosis for someone treated with this condition today?
So unfortunately, some patients do not do very well. It can occur where a patient receives chemotherapy and a transplant, and they can be cured. It does certainly happen, and in about roughly 40 to 50% of the time, they get a really good longer-term outcome. Unfortunately, for the remainder of patients, majority of patients, they relapse their cancer. One of the issues in that circumstance, if you've relapsed after a stem cell transplant, your outcome there is terrible. So your 2-year survival, so your likelihood of living another 2 years is less than 20%. So there's clearly an unmet need there that needs addressing.
One of the issues with hematopoietic stem cell transplantation is that patients who receive these transplants are not able to use other therapies. Can you explain that and what the consequence of that is?
Yeah, sure. So you can kind of think of it akin to, planting a new garden, where of rich soil, you're putting the seed in, which essentially is this new hematopoietic stem cell transplant, and now you're growing out a new crop, and it looks great. However, other things happen. Of course, weeds can pop up and even overtake your garden, and that's exactly what happens in a stem cell transplant. You end up clearing the bone marrow using high-strength chemotherapy or radiation, essentially making that enriched soil, but then planting seeds and hoping for that to take while trying to suppress the weeds. And unfortunately, unlike a garden, you cannot weed out a bone marrow. And so what ends up happening is that the cancer returns, and it can return very aggressively. And one of the issues is that you cannot use anti-cancer therapies in this post-transplant period, because simply anything you give at that period to treat the cancer will also affect the stem cell transplant and kill the transplant. If you kill the transplant, you will also kill the patient. And so that's part of the difficulty here. You're stuck. You've just given a transplant, you're expecting it to take, but you're really limited in your treatment options.
Listeners may be familiar with Siddhartha Mukherjee, author of The Emperor of All Maladies. He is Vor's scientific founder and developer of the company's platform technology. What was it that he did, and how does Vor make hematopoietic stem cells that are resistant to targeted therapies?
Yeah, so Siddhartha Mukherjee's brilliant innovation was actually to approach this from an angle where you the cancer in entirely different ways. So in a stem cell transplant, you have cells that are outside of the body. You're taking it from a healthy donor and then infusing that into the marrow cancer patients. And there's an opportunity there where you can process these cells and effectively render them resistant to therapy. We are doing that through sophisticated gene editing techniques. And when you do that, we are rendering these cells hopefully totally immune to targeted therapies, which you can then use in this post-transplant period where you'd normally never treat the patient. Thereby, you're creating a new treatment opportunity soon after the transplant and hopefully keeping the cancer at bay, or potentially at best, working towards a cure.
Your lead candidate is VOR33 for AML with a companion therapy, VCAR33, a CAR T therapy that targets the CD33 receptor. What's the rationale for this?
Sure. VOR33 is a hematopoietic stem cell transplant that has a particular gene edit removing expression of a gene called CD33. CD33 is expressed strongly in 90 to 95% of AML patients. It's expressed in other diseases as well, where the role of CD33 is not entirely clear, but what we have demonstrated time and again is that you don't seem to need CD33. It's a molecule that shows signs of biological dispensability, meaning that you can delete it out and nothing untoward seems to occur to these cells. And so what we're doing is we are using genome engineering techniques to remove CD33 expression in these hematopoietic stem cells and providing that as a substitute for the regular stem cell transplant. Now, what that then does is open the opportunity for targeted therapies in this post-transplant period. And as you mentioned, Danny, one of the drugs we're working on is called VCAR33. And in VCAR33, this is a living drug, a CAR T, like some of these therapies that have been recently approved. CAR Ts have the opportunity not just to hunt down a particular target, in this case, CD33, but they have the ability to live and persist for months to years as a living drug and functioning to remove any source of that target. And so that's the vision here, that we can replace the standard of care transplant with a genome engineered transplant like VOR33 and follow it with a CAR T such as VCAR33 that can live for months to years to sniff out any signs of cancer.
What's known about your approach from studies that have been done to date?
Yes, so we've studied this in vitro models, in vivo, and also human genetics. So in vitro, you can delete out the gene and study how these cells function. In vivo, you can put these into engraftment models like in mice or monkeys and study how these cells function without the gene. But the human genetics is also really interesting, where there's actually a subsegment of the population who have never ever expressed CD33 before. And that's really interesting because clearly these people have been developed and born and functioned even through late stages of adulthood without ever expressing CD33. And so that gives us some confidence that CD33 is not biologically necessary for hematopoietic stem cell function.
As this approach opens up the potential to use stem cell transplants in combination with other therapies, what are the range of indications you're looking at?
So CD33 is expressed on a variety of different cancers. So about 90 to 95% of AML. It's also expressed in related conditions such as MDS or myelodysplastic syndrome and some myeloproliferative neoplasms, MPNs. It's also where we are pursuing this target in combination with other targets. So we've looked at other myeloid targets such as CD123, CLO1, EMR2, which could also be very useful for these kinds of conditions. And we're really expanding this to other kinds of cancers, such as T-cell lymphomas, where CD5 is one of these targets that's strongly expressed on T cells, and that could be a very interesting approach way beyond myeloid disease and applying the Vor platform towards other blood cancers.
What's the potential to change outcomes for patients with AML and other hematological cancers?
So we have quite an aspiration, Danny, at Vor. We're not in this just to incrementally change standard of care. We're in this to cure people, and I don't necessarily use that term lightly. Cures are really hard to do, but I know that if I had cancer or if a relative of mine had cancer, this is the kind of approach that I would want. We want to create totally new opportunities to treat patients and essentially hit the cancer when it's down, such that you can approach this cancer in a totally different way towards lasting benefit. And we think that this approach in AML would be a revolution if this actually worked the way we think it does. And going beyond that broadly to other blood cancers really is what we'd like to do and really what motivates people at Vor to come to work.
What's the development path forward?
So we are in a phase 1/2 trial right now. It's called VBP101. This is enrolling patients in 6 sites, soon to be more, around the US and North America, that is targeting patients at high risk of recurrence of AML. So in this study, we are replacing the regular transplant with our special transplant, VOR33, and we're following it up with a targeted therapy called Mylotarg, which is an antibody drug conjugate targeting CD33. So this trial is open right now, and we're enrolling patients, and we are planning to read out data later this year, hopefully demonstrating robust proof of concept that CD33 is truly biologically dispensable, as we've mentioned, and that you can use agents such as Mylotarg, the CD33 ADC, without the typical dramatic heme toxicities that you would expect from it. Now, if those data points read out the way we think they do, I think that really validates our whole approach and opens up all kinds of avenues for further study to broaden patient populations and look at additional targets.
Vor completed a $200 million IPO in February 2021. How far will existing cash take you, and are there plans to raise additional capital?
Danny, we have guided that we will have cash into the first quarter of 2024, and that's really nice. That being said, I think that cell therapies are a capital-intensive business, so we'll be looking for additional sources of capital sometime in the future. But for now, I'm just really grateful we were able to raise that $200 million at the beginning of 2021, because that's really set us up towards a long runway to demonstrate that our concept actually works, and to then establish solid plans in the future to really broaden this approach for additional patients.
Like a lot of companies in the sector, Vor has seen its share price down significantly from its highs. You're trading around $5 a share, well below the $18 IPO price. What's the conversation like with investors these days?
You know, this environment is not being kind to any of us. And I think the investor community is similarly hurting. That being said, Vor is one of these lucky companies which is well capitalized, has a great management team, and is poised to read out data relatively soon. So from that standpoint, we're incredibly grateful for where we are. And I think investors are really embracing the fact that we have data coming soon, are very much looking towards that, and hopefully demonstrating to the world that this works just like we planned it out.
Robert Ang, President and CEO of Vor Bio. Robert, thanks so much for your time today.
Thank you, Danny.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send an email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.